Okay, so we're going to look at what I call the straightforward equilibrium calculations. This is the 2007 question. It will be more than likely a question 7, a question 8, a question 9, so as part of a full question, or as part of question 10 and 11 where you answer 2 parts out of 3. So 2007 is a 2 parts out of 3 question, and we read down through it, write your equilibrium constant expression for this particular reaction. So we know that the products go on top, that we have to have square brackets because they infer moles per litre, and the number 2 in the formula is going to give us the power. So NH3 square brackets squared, it's going to be divided by N2, and because there's no number in front of N2, there's no power, and H2, because it's 3H2, is going to be to the power of 3. So that's the first thing we do. The next thing that we do is we have to work out our initial concentrations and our equilibrium concentrations. So I always just write my reactants and my products here as like column headers. The ratio for the equation I give as a value of x, so because there was 1 N2, we call it x. There are 3 H2, so we just are going to call this 3x, and for NH3, because there are 2 of them, we call this 2x. Now what that's going to do is that when we get to our equilibrium line, our reactants are going to change by their x value, and our products are going to increase by their x value. So on our initial line, we're reading our blurb in our question, and we have the idea that we have 3 moles of nitrogen mixed with 9 moles of hydrogen, and it is in 1 litre. So the rule is things have to be in moles per litre for us to be able to use the numbers. So in this case, both of these numbers are free to use. I don't have, say, 10 litres of stuff, so I don't have to divide 3 by 10 to figure out moles in a litre. And the rule is for our reactants, it's always 0. Now, just be aware that when you're reading the information of initial, there has been a question where the information for the initial was actually for the products. And because these are reversible reactions, then that's absolutely allowed. So just read it carefully and make sure you are content with that. Okay, so that's our initial line set up. We look at our product line then, and so our product line would be 3, it'll change by minus x, and 9 for our hydrogen will change by minus 3x. And then we have to just read our question to see can we find any other pieces of information that will help us, and it tells us that there are 2 moles of ammonia in our vessel at equilibrium. So the 2 moles of ammonia again is still in a litre, so that number I can use. And I like to box things to know that I'm going to use this number in my Kc equation to help me. And the reason I'm doing this is because this 2 moles here is equivalent of 2x. So to find out obviously what x is, I divide both sides by 2. So 1 mole in a litre is now equal to x. And I am now just going to put that into here and into here. What can happen is candidates get confused and they then think that this is the number that they're going to put up here into our Kc equation, and obviously then their numbers are wrong. Okay, so just please be aware of that. So inputting my value for x, 3 minus 1 is equal to 2. This is the number I'm going to be putting into my Kc equation, and 9 minus 3 is equal to 6. This is the number that I'm going to be putting into my Kc equation, and I'm ready to go now. So I fill in my Kc equation. That is going to be equal to 2 squared all over 2 by 6 cubed. And when I do that piece of maths, I get 0.009. And I just always ask that you make sure that once you've finished your calculation that you've answered the question asked. So if you go back and look at our question up here, it says calculate the value of Kc for this reaction at this temperature. So this is now my final answer.